This is the answer to Chapter 10, problem number 49 from the Smith Organic Chemistry textbook. And this is a thermodynamics problem. Thermodynamics is many people's least favorite part of chemistry. But it's just math. So the problem says by using the bond dissociation energies in Appendix C, calculate delta H naught for the addition of HCl and HI to ethylene to form chloroethane and iodoethane, respectively. Assuming entropy changes for both reactions are similar, which reaction has the larger KEQ? And so we're going to assume that entropy changes are similar. So the KEQ is going to be dependent entirely on the delta H naught of the reaction here. And so the more negative delta H naught is going to be the one that has a larger KEQ. And so basically for each of these, we just need to use the table Appendix C, and we need to get the energies of these bonds being broken and formed, and then add them up for each reaction. So starting with the formation of iodoethane here, so we have a carbon-carbon double bond that's going to break, and the breaking of that bond is going to require 267 kilojoules per mole. So that's going to be 267 kilojoules per mole. And then the HI bond is going to have to break. And that's going to be 297 kilojoules per mole. So then this is 297 kilojoules per mole. And then on the right side, we're going to have the bonds that are formed. And so we're going to have the addition of a hydrogen to this molecule. And so that is going to be worth negative 410 kilojoules per mole. And then we're going to have the formation of a carbon iodine bond. And that is going to be worth negative 222 kilojoules per mole. Okay, and so now we just need to do this math. So on the bonds breaking side, when we add these two numbers together, we get positive 564 kilojoules per mole. And on the bonds forming side, when we add these numbers together, we get negative 632 kilojoules per mole. Okay, and when we add those two numbers together, we get negative 68 kilojoules per mole. And so that is the delta H naught for this reaction. So negative 68 kilojoules per mole for the formation of iodoethane. And now we'll do exactly the same thing for the chloroethane. And so the carbon-carbon bond, carbon-carbon double bond breaking is not going to change. So that's still going to be 267. The chlorine hydrogen bond breaking is going to be worth 431. Okay, and that's going to give us a total of 698. So positive 698 kilojoules per mole here. All right, and then on the right side, we're going to have, again, the addition of a hydrogen to this molecule, and that's going to be worth negative 410. Okay, and then the carbon-chlorine bond forming is going to be worth negative 339. Negative 339 kilojoules per mole. And when we add those together, we get negative 749 kilojoules per mole. And when we add these two numbers together, we end up with negative 51 kilojoules per mole. Okay, and that's the delta H naught for this reaction. Okay, and so now we just need to compare negative 68 kilojoules per mole to negative 51 kilojoules per mole. And so negative 68 is it's less than negative 51, but it's the larger negative number. And so since we said entropy changes are going to be roughly equal, we said KEQ is going to be dependent entirely on which of these reactions had the more negative delta H naught. And so that's going to be the formation of the iodoethane. And so this is going to be the larger KEQ. Okay, and so that's the answer to this problem. And again, in order to solve it, you just have to do a little bit of math. You use the table in Appendix C. That's going to give you values for all the bonds that are being broken and formed. And then you just need to add up all the bonds being broken, add up all the bonds being formed, add those two numbers together, do that for each reaction, and then compare the two numbers. And that's the answer to Chapter 10, problem number 49.